Alright, hello again everyone. Mr. Hutner here. Hope you're all doing well. So we're going to pick up today with 8.2 Graph Simple Rational Functions, Day 2. And you can see this time the general form we're graphing, y equals ax plus b divided by cx plus d. And so first thing we're going to address today is how that affects the asymptotes. The first asymptote occurs at x equals negative d over c. Now this is not something that you're going to have to remember or memorize. It's easily found each time we do a new problem. It's from yesterday. We know one of the asymptotes occurred whenever the denominator was 0. It's that divide by 0 problem we had. So if we take the denominator, cx plus d, and set it equal to 0, we know that's not allowed. So whatever x value makes this happen would be where the asymptote occurs. So if I do minus d on each side, that's cx equals negative d. And then you can see with a divide by c on each side, we end up with x equals negative d over c. The other asymptote occurs at y equals a over c. Now this one is one that we're going to pay more attention to, kind of have to remember it. The nice thing is it's easier to remember because if we check that general form that we're graphing again today, you'll see right over there, it says y equals a over c. So it makes it easier for me to remember at least that it's like kind of right there written into the problem. It also ties nicely into the work we did yesterday. So we'll put that on hold for now. That's our asymptote. We'll talk more about that in a moment, but it fits together with what we learned yesterday. Yesterday we graphed y equals 1 over x, which looks different than what we're graphing today, but think the top didn't have an x, so if there wasn't an x there, that must have meant a was 0. So there's 0x, there's the 1, plus 1. While in the bottom, here there is an x, so that's the 1x right there, that's c is 1x. But you see there's nothing else down there with it, so it's kind of like there's a plus 0, like that d is plus 0. So see how this is really the same thing we were graphing yesterday, just written in a more complex form. Well, now if we focus on the a over c, that would be this 0 over 1. And 0 divided by 1 is 0, and sure enough, that's the same as the asymptote we saw yesterday. So that's just some background info there about how what we're graphing today and what we graphed yesterday are related to each other. Let's go ahead and try our first example. So now if we come over here and check out y equals 2x plus 1 as well as then divided by x minus 3. What we see is that we're going to check those asymptotes again. So the first one is when the denominator equals 0. So add 3 to both sides. There's an asymptote at x equals 3. I'll go ahead and put that on the graph. That's the vertical asymptote where x is always 3. For our other asymptote, we're looking at y equals a over c. In this case, a is 2 and c is 1. So I'm thinking there's an asymptote at y equals 2. That's our horizontal asymptote where y is always 2. So now just like yesterday, we're back to like making an xy chart. Gonna pick some x values that are centered around x equals 3, maybe values like 1 and 2. Then I'm gonna skip 3, go for 4 and 5. So then we'll use input-output to see if y equals, and I'm going to put x is 1 in the problem. 2 times x is 2 times 1 plus 1, and then in the bottom x minus 3 becomes 1 minus 3. So up top that's 2 times 1 is 2 plus 1, and in the bottom 1 minus 3 is negative 2. 2 plus 1 is 3. And then over negative 2, that's like negative 1.5. You can check the other ones yourself. When you substitute x is 2, you should get y is negative 5. When 4 goes in, 9 comes out. And when x is 5, y is 5.5. So go ahead and put those points on the graph here. That's right 1 and then down 1.5. That's from the origin here. So right 1, down 1.5. Then right 2. And down 1, 2, 3, 4, 5. The other points are right 4, up 9. So that's going to run off my graph here. We're going to kind of guess there, but right 4, 1, 2, 3, 4. and then up 9. This is a total of 7, so we're going to go, that's about 8. That's about 9 right up there. Okay, and then right 5 up 5.5. So that's 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5.5. So right about there. So same as yesterday. Now thinking of how to connect those points and also respecting the asymptotes we have. I'm thinking one of them would look kind of like that. And then the other one kind of like that. So now another chance to talk about that y equals a over c asymptote and make some sense of it is you notice here it's this horizontal line where y is always 2. And you see our graph gets close to that either as we go way to the left, or you can see it's getting closer here as we go way to the right. So that's either as x is getting really big or really small. Think like positive infinity and negative infinity. So let's focus on the positive side. And basically it's as x keeps getting bigger, this graph keeps getting closer to 2. So let's check like when x is 10. You can see that would be like 20 plus 1, that's 21. And down here 10 minus 3 is 7. 21 over 7 is 3. So that would be somewhere up above the asymptote here. But not real close, right? A whole space above. So then we think of like farther down the line and think like when x is 100. Then this would be 201 divided by 97. Now 201 divided by 97 is 2.07. So now you see we're still above this asymptote, but we're much, much, much closer. And then think of it as it gets to like 1,000,000. And that would be like 2,000,001. And then down here it's 1,000,000 minus 3. That would be 999,997. Basically the plus 1 and the minus 3 start to matter less and less when you deal with numbers like 1,000,000. If you have $1 million and you get one more, you don't really care that much. And what happens is this 2x over x becomes much more important, where if it's 2 times 1,000,000, that's 2,000,000. But down here, this would only be 1,000,000. And 2,000,000 divided by 1,000,000, there's where we get that ratio of 2. So as x gets bigger and bigger, our answers keep getting closer to this boundary of y equals 2. But it'll never exactly get there. And then let's try one last example to wrap this up. So this time we're just going to jump right in. I'm looking to set the denominator equal to 0. Find one of my asymptotes that way. So I'm going to add 1 to both sides. Then divide by -1 on both sides. So I find x equals -1 for one of them. Then I'm going to do y equals a over c. And this time that would be y equals -3 over -1. That's y equals 3. So let's go ahead and get those on here. That's x is always -1 right there. And y is always 3 right there. For the rest of the xy chart, you can check your own input-output if you want. I'm going to go ahead and fill it in. I had x values at -3, -2. Going to skip right over -1 and go to 0 and 1. And corresponding y values. When x was -3, we got y is 5.5. When x is -2, y is 8. When 0 goes in, -2 comes out. And when x is 1, the output is 1/2. So that's left 3, up 5.5. 1, 2, 3, and up 1, 2, 3, 4, 5.5. Right there. Then left 2, up 8. So that's going to jump off my graph again. If that's 7, that's about 8. And then 0, -2 is don't go left or right, just go down 2. And finally right 1 and up 1/2. So again, with respect to the asymptotes, I'm going to draw my hyperbola with curves there and there. And then let's also revisit domain and range. Remember, the domain and range are both all real numbers except for wherever the asymptote occurs. So here we have a domain of all real numbers except when x is -1, and here we have a range of all real numbers except when y is 3. That's it for today. Thank you for watching. At this point, go ahead and try the few practice problems that you were assigned for today. You can upload them to our Google Classroom, and thank you very much.